it's typically pretty hard to see exactly where we evolved from, and some of the questions aren't necessarily really easy to see. And so when we think about this stuff, I just kind of want to walk you through some finds and discoveries that we've made in human evolution, and give you a little bit of a understanding of the importance of those. So sit
All right, so here we are, taking a look at some of the information, ask some questions, and hopefully get to the bottom of some more of the evolution. This should just kind of be a general summary for the unit, combining all the things that we looked at in class and notes, labs, things. So the question is, what really is human? When does the human lineage begin? Is there a certain marker? One of the questions that someone asked me in class is like, when were the first humans? Well, it's somewhat hard because, what is human? Like, obviously, we look at these paintings and said a human had to do this, that it couldn't have been done by an ape. This is human. But then the question is, would this be human? Is this something making just tools in general a characteristic of humans? And so it makes it somewhat interesting to look at where these occur, and hopefully you'll realize it's not a specific right at this point. It's more of a gray area. So Homo habilis evolved around 2 million years ago. Obviously, the name Homo habilis, they used tools. They were still scavengers. Lived in communities much smaller than our modern humans were. And then what we're going to do is we're just going to look at what makes a human. And there's basically two ways to look at this question. You can look at it on the one hand from a physiological, our bones, our structures, and we also can look at it from the standpoint of what makes us human based on traits that we do, like communication and fire and things like that. So if you kind of look at the family tree here, this is kind of what we believe to be. There are some missing links. That's okay, right? Not all fossils are going to form, but you can kind of see where our breakoff is going to be is up in this region here from chimpanzees and gorillas back in the hominid lineage. And we talked about this already about how we know that Australopithecus afarensis is going to be that ancestor linkage to us, eventually going through the genus Homo and then to Homo sapiens. You should be able to look at this and on the test be able to kind of differentiate different species and their relatedness. We talked about this already about where did primates come from. They would have came from a tree shrew. But the other question is, what do you have? So you got these creatures of primates. They're going to have better daytime vision. They're going to have eventually some upright walking. Their grip is going to be a power and precise grip, which basically means that you can grab hold of something, hang on for dear life, but you can also be able to do painting and drawing and a lot of delicate work. One other thing to note that's interesting is as you look at this relationship that we have in the humans, how we have much longer infancy, longer subhuman. Obviously, our adult stage is about the same length as the chimpanzee and other animals, but we also add this post-reproductive years, which is not seen in any other species. It's just kind of an interesting little side note. Our first hominids would have appeared around 5 million years ago. There were some ancestral primates that would have been around from about 36 million years ago, evolving from the old world prosimians. But the actual, what we think of as hominids are related to us, would have been right around 5 million years. A couple interesting things that you should note is if you look at the skull of an infant chimpanzee and an infant human skull down here, look how relatively similar they are. I have an example of this in class. What changes is if you were to kind of map out the skull, you can see how developed their jaw becomes, how the brain for ours, actually relatively speaking, the relationship stays the same. They get a much larger growth in this area down here, which we tend not to see in humans. And do notice how a lot of scientists, and we'll talk about this term in a second, the humans actually look like a miniature or an underdeveloped chimpanzee, that the skull of an infant and a human physically have some similarities. We call that concept padiomorphism. So we talked about these skulls. When we look at a couple terms that get commonly mistaken, hominidoids up here, a lot of times gets mistaken for hominids. That O in there refers to apes and humans. So there are other types of hominoids that are alive today other than humans. It's all your gorillas and chimpanzees. But they're the only species of hominids left today are humans. The rest of these down here, they all went extinct. We talked about this already. This is an important question that you should be able to answer on the test. The changes that occurred based on the Isthmus of Panama is going to greatly change the evolution of North America, but more importantly, it's going to change Africa. For our class, the first species that we're going to really focus in on are the southern apes. We call them in the genus Australopithecus. There are several different types of southern apes. But the problem is that we don't have enough fossils to differentiate them, to know exactly which one's which. So the best way or easiest way to do that is by putting them in large groups. As time has gone by, we have created other subspecies or subgroups of the Australopithecus. But once again, it's mainly due to the fact that we don't have a lot of quality fossils, which would be necessary to break off or differentiate between different lineages of Australopithecus. A common trend that you should see is that, number one, that all these hominids, as they come around, get bigger brains, their faces, their mouths, jaws decrease. They also get better dexterity in their fingers, and will have a better power and precise grip. All of this is occurring from that 5 million to 2.5. So the problem is, where do you draw the line? Where do you separate one species from another? It can create a kind of an interesting situation or problem. We can't actually necessarily see it. We do know that those Australopithecus are going to give rise to Homo habilis, and Homo habilis, without a doubt, is believed to be one of the first primates, first hominids to actually use tools. That stone axe up there would have been one of their primitive tools. Okay, their brains would have been much bigger, and they're not going to have, in the video pointing this out in class, they don't want to change. They're not inventive anything more than that stone tool. Their stone axes don't get much better. So even though they are pretty intelligent, they still lack a lot of what we would think of as common intelligence. This diagram is really important. I'd kind of maybe take the time to look at this. What this refers to is, on the bottom axis here is the body mass. In other words, the weight of these organisms. And then when you look across on the axis going up the side there, you have the brain case volume, so how big the brain is. And if you notice, there's this nice trend line on the bottom here. Nice little trend line that happens. So all species of great extant, that means living today, kind of follow this. That you can kind of make a prediction. If we found a new species, you could kind of figure out their body mass, be able to figure out their brain capacity. Australopithecus, we see that same trend here, okay, that as they get bigger, they get a little bit bigger brains. What's unique is now all of a sudden, when we look at the genus Homo, and the three types, Homo habilis, Homo erectus, and Homo sapiens, how much larger their brain is. Look at that best fit line, the different slope that it has versus those. We see a dramatic increase in brain development, much more than we expect down here with the great apes and the Australopithecus. So it's a really interesting visual. If you're like me and charts and graphs make sense, it kind of pieces things together a little bit better. This is another interesting little diagram here with, if you look at a human thumb versus a chimpanzee thumb, notice there are some changes that occur with a little bit adding the muscles and the attachments and ligaments here. The increase not only in the number but also the strength. What's this going to create is a thumb that can actually move backwards, give us a lot more round motion, and you can kind of move this in a circle. And so by simply having this, it makes our thumb not only a power thumb, like the chimpanzees, but also much more precise. We can grab, we can paint, we can do all that kind of cool stuff. One other thing is, as this is occurring, there's this change in the metacarpal, so that's a bone in your hand, and you can see there's this general trend line. We're getting elongated metacarpals, allows for better grabbing, better grip, all those things that would be necessary for early humans to be able to manipulate their environment. And once that, along with the good eye vision, is going to help. An important thing is, a lot of times people say, well, I don't really think humans are very ape-like. They don't really look like them. When we look at the molecular evidence, there's a strong indicator of how closely related we are to the African great apes, the gorillas, and specifically chimpanzees and bonobos. When we look at the study of our DNA and the study of our mitochondrial DNA, there's very close similarities. Okay, and because of this, we can easily group ourselves into that same grouping. The things that changed from those, you can kind of see. We shorten the canines. Our wrist becomes more of a fused wrist, which allows for prevents the upright walking. We get enlarged ovaries, and then we also lose hair. This is basically if we look at a breakdown of the different humans with the great ape species. Some people have an issue of exactly how closely related we are to them. When you actually look at the DNA, it's pretty darn close. So this is a diagram that I think is interesting. When you look at the mitochondrial DNA, it goes to show that humans and chimpanzees are more closely related than chimpanzees are to gorillas. This is a really interesting little information here, because a lot of times when you look at a chimpanzee and you look at a gorilla, you make the assumption that those two are more closely related. But when we actually look at the mitochondrial DNA, we actually see that we are more closely related to chimpanzees than they are to a gorilla. There's also genes found specifically on the Y chromosome, and when we look at those, the same kind of prognosis can be made, that there's this 99% similarity between humans and chimpanzees, where there's only a 95.8% similarity between chimpanzees and gorillas. So if you're acceptable with putting gorillas and chimpanzees in the same clade, same grouping, then humans should easily be able to be put into that class or association. This is just looking at some specific genes, same concept. I just wanted to give you a bunch of different examples and understand why we believe we are closely related to chimpanzees. And you can see how much more similar we are to chimpanzees than to other species. Last part of these notes, I just have a couple different skulls and a couple different just major notes, I guess you should say, that you should have in your notes already, but just as kind of a quick summary or review. So here's the first one is Homo erectus. Once again, translates upright man. I like this fossil because of that injury here. There was some signs of injuries and damage, stuff like that. They have fire, they have clothing, okay, greater social structure, all those things that would be important for humans we see first in Homo erectus. They were able to first to leave Africa, first to use fire, first to be big game hunters, a lot of major firsts, and they were around for over 1 million years. Major accomplishment, a lot longer than we've been. Modern humans, once again, where do we fit in that? For about 170,000 years, that's when Neanderthals came about. We're not exactly sure what happened to the Neanderthals. Once again, we believe the most likely scenario is that they merged with us, but the exact information is not necessarily known. You can look at the kind of family tree of where we are at based on our relationship and relatedness. Obviously, Homo sapiens are the ones around today. We believe we evolved from kind of an ancestor of the Homo gascar, which a lot of times is grouped together with Homo erectus. The furthest back, if you really look at how far human races actually went back, it's only about 30,000 years. That's not a very long time. Once again, I think this is one of those things where I think why racism is stupid. The simple fact that everyone originated in Africa, and the fact of how closely related we are actually to all the different people on our planet. Homo sapiens themselves have been around since about 40,000 years ago. And once again, if you look at our book or all our notes, we're talking kind of, that's based on culture and the idea. We have a lot of other traits that have evolved in that last course of that time. Things as color, light skin, lactose intolerance, sickle cell anemia, cystic fibrosis. We also do operate outside of evolution to some degree because we are able to manipulate our environment, change our environment, and live in places that normally we wouldn't be able to. All right, that's all I got for today. Tomorrow I'm going to post another video, which I'm going to go over some review guide questions, and I might even throw some test questions on the video to see how well you guys are able to answer that. So tune in tomorrow. I'll post that one as well. Have a good day.